Okay, so this is the complete working model of a digital clock. So it is made using 4 7 segment displays. So these are common cathode, and each of the 7 segment displays has 8 pin. So now this is an Arduino Uno. First, let's verify the time. So it says it is 9:12. It is 9:12, 9:13. It will turn 13 in no time. So let's proceed. So this is an Arduino. It has some digital pins, some analog pins, and power input. So how this is working, because we know that we are using 4 7 segment displays, and an Arduino doesn't even have that much pin to control 2 7 segment displays, and here we are using 4 of them. And trust me, I can even use 8 or 9 of these displays using the same Arduino. It will just increase one more wire for each of the 7 segment displays. So now how does it work? So you can see these messy wires up and down. So these wire then so these wires are connected parallelly. Now you see a 7 segment display. 7 segment display has these mini LEDs connected to each of the pin with a common cathode. So if we provide a current if we provide a particular voltage to the common cathode and to the specific pin that is connected to the specific LED, and we do it in a pattern, then the display will show a digit. It depends on how and in which pattern we have provided the voltage. It will light up and a number on that particular display. So now how we are doing this? It is that we are using a technique called multiplexing. So what is happening here? It is controlling, this Arduino is controlling one at a time, but in a very high speed that we can't catch through eye. But you can see that in the camera that it is flickering, but it cannot be seen through our naked eye. So you can see it more clearly when I slow down the shutter speed or the frame rate. Wait. Okay, now you can clearly see the switching. It is controlling one at a time. Two for this, one for this, one for this, and five for this. It can't be seen when I turn back to normal. This is the normal frame rate, and trust me, it is same as seen from the eye. So now this is how it works, and it will keep telling the time until this battery drains out. So yeah, this works just fine, and we can keep adding like up to 10 7 segment displays. Two here I will add up for future, in the future, two for the seconds, to display the seconds in this digital clock. And we can't add up like many of them, because it has to switch in like 4 milliseconds per 7 segment display, and it can put up heavy load on this, because it works on a immensely low 16 megahertz frequency. That is not good for this type of IoT projects. But I can use ESP32 programmable port for this, and I will update this in future.